morning. Today is going to be about learning the connection between marine currents and ecosystems and how they affect the climate, as we talked about. And the first thing I want to talk to you about is the thermohaline circulation. So today we're going to learn about saltiness, salinity, and also the warm and cool water and how they affect each other. Now I'm going to hand out the worksheet here, and I want you to look at it, and I want you to talk about it just in the table groups that you're in. I want you to talk about what you see. Okay, come.
So where the blue line is the deep current and cold water, and where the red line is the shallow and warm current.
Yeah.
And then the little yellow is where it sinks or there's surface.
Yes. Okay. So in general, it's what? The movement of what?
The water.
Of currents.
Of currents. Okay. So we need to establish a connection. So we need to know why does it sink or surface, and we need to do a thesis. Now, can anyone figure out a way to test why water that is warm does something alternate than cold and saline water? We have some bowls with water here. Can anyone think of any way to test if we have any connection between those? Yeah.
Well, you could try mixing them, right?
Yeah.
Or putting something in them that we know is pretty neutral and see where it sinks fastest. Or you could just put them on top of each other with some color in maybe so you can distinguish them, right?
So what would happen, for example, if we mixed salty water, saline water, into more fresh water? What should happen?
Salt is heavier, so the salts would sink to the bottom, right?
Yes.
In salty water.
That is our thesis number one. What should happen when we put salty water into fresh water? You said it would sink. And what would happen to cold water if we color that? What would happen if we put it into a warm basin?
It would sink too.
It would sink too. Okay. I want you to carry out that experiment and prove the thesis. And I want you to do it in small groups. Okay, so what happens?
It also goes down to the bottom.
So it's
water? Does it sink or surface?
It's surface.
Okay, so does that correspond to our thesis?
Yeah.
Okay.
It does, yes.
Amazing. You can just put it
Okay, and what happened to the cold water as you poured it into the room temperature water?
You could see that it like sank to the bottom of the bowl. You could see like the color was more like bright in the bottom.
Good job. Okay, so did that correspond to our thesis about density of water?
Yeah, it being heavier.
Okay, good job. Thank you. And group number two, what happened to your experiment?
We put salt in our water,
Yeah.
and then we found out that the salt is heavier. Salt water is heavier.
Why? What happened to the salty water when you poured it in here?
It fell to the bottom.
It fell to the bottom, meaning it's heavier. Good job. And the final group here, which experiment did you carry out?
The one with the hot water.
The one with the hot water. Okay, so you had room temperature water and you had hot water, represented in red. What happened when you poured it in?
The hot water floated to the top.
Yes. Okay, so it surfaced. Nice. Okay, so the climate is getting warmer, which heats up the surface of the water. Also, we're melting the ice at the poles, making the water fresher. we are doing things to this thermohaline circulation. Now, where do we have the vertical mixing? Where does it happen around the globe?
Around the Pacific Ocean, there's a little bit, and in the Indian Ocean,
Yeah.
and the Atlantic Ocean.
Exactly. And is it in the middle of is it around a crater or is it around the poles?
It's like at the top.
Yes. Okay. And do you have any explanations as to why it would be up there and not in the middle?
It's closer to like the Arctic Ocean.
Exactly. And what happens up there?
It's cold.
It's very cold.